Good afternoon, everyone. Thank you for sticking around until the very end. My name is Liz Fong-Jones, and I'm going to be telling you about what happens after your code reaches production and how we can make that better. Buenas tardes a todos. Me llamo Liz Fong-Jones y hoy hablaré sobre los sistemas complejos y cómo podemos hacerlos más confiables. Y porque hablo un poco de español, pero no hablo suficiente para hablar sobre un sujeto técnico para 40 minutos, entonces hablaré en inglés, pero todas mis palabras también estarán en español también. So, as developers, we like to solve problems. We like to write code in order to feel like we're having an impact on the world. But the problem is that solving problems doesn't really just stop from the moment that we commit our code and land it into Git. We have to actually make sure that it's serving our users and making them happy. And as our systems grow more and more complex, it's much more difficult to understand what's actually going on. How can we make sure that our customers are having good experiences? How can we be sure that when things actually get deployed into production, for instance, when they're running on someone's Android device, or when they're running on millions of web browsers, how do we make sure that everything is still working as we planned? And what does it even mean for a system to be up or down? A long time ago, it used to be possible to say, I care about whether I can ping my server. If I can ping my service is up. And if I can't, my service is all the way down. Well, that doesn't really work anymore. Nor is it a good idea to measure whether our service is working by the number of people that are calling into our call centers. The number of complaints, by the time that you get to that point, you have some really severely unhappy users who are considering taking their money elsewhere. And what about the fact that when we're not worrying about uptime, we're also having to deal with feature development. We're also having to think about how we might refactor our code. And we also have to think about how are we structuring our system to make everything better. And if you don't have your systems and your people set up in order to juggle all of these challenges, you're going to have your people feeling like they have no time to work on everything, and they won't feel like they're actually getting anywhere with their work. We have to pick different strategies that enable us to be more successful and to enable our employees to have their efforts be more sustainable in their work. So the first thing I'm going to tell you is that despite the fact that I work for a vendor company that sells tools, do not buy DevOps. You cannot buy DevOps. DevOps is something that has to come from your people. It cannot come from your tools alone. When you order things off of the menu and order the alphabet soup, you wind up with a big, giant mess. For instance, what happens if I decide that I need some continuous integration and continuous delivery in order to ship code faster, regardless of the quality of it? Let's ship code as quickly as we can, regardless of the quality. That's going to make everything better, right? Well, hold on a second. That might not be the best thing to do. Or what about infrastructure as code? If we put everything into Terraform, then instead of being able to take one AWS server down with one click, we can take down our entire infrastructure with one click. That's going to make everything better, right? Or what about Kubernetes? I hear Kubernetes is hot. I want a Kubernetes. I don't even know what a Kubernetes is, but I want one. That's the right thing to do, right? Or what about PagerDuty? Why don't we put every developer on call, even if the on-call situation is miserable and people are disempowered from doing anything? That's going to make everything better, right? Is this sounding familiar to a lot of people? Sure hope it is. I see a lot of places where that happens, unfortunately. And what happens when you do that is that you wind up waking up very, very often in the middle of the night. you wind up having your pager constantly going off because you can't tell what's an actual emergency and what's been generated from one more alarm being added to the pile of alarms. And when you do start looking into those alerts, what you quickly discover is that there are too many different places to look. So many places to look that you no longer know where to start looking. Because you probably have a collection of dashboards which represent the last 10 or 20 or 30 incidents that you had, because everyone loves saying in their incident retrospective, let's add a new dashboard, or let's add a new graph for that so that we can catch it next time. And that just makes your job much, much harder. And when you add on automatically generated dashboards that your monitoring vendor has sold you, you wind up having dozens of different pages, each with hundreds of graphs, and you can't make sense of any of it. And as a result, buying the alphabet soup doesn't actually bring down the time to recover from incidents. We have to be able to repair the state of our systems as quickly as possible in order to make sure that our users don't become too unhappy with us. So if we're not actually achieving the objective of decreasing the amount of time that our users are affected, maybe we should figure out what we need to do differently. Another common situation that I see is that people often have experts on their teams or are the expert. Yeah, I'm sheepish. Sometimes there are some things that I'm a single point of failure for, and that's not great. When you have a single point of failure, when you have all of the knowledge locked in one person's head, it means that person can't get any other work done because people are constantly bugging them all the time about things that they don't understand, and therefore that person doesn't even have the time to document and write down what they know. And if that person goes on vacation, well, then the site's going to break. And that's not okay, right? Often, I also find that people continuously integrate and deploy individual components of their code, but they don't have a great solution for figuring out, how do I know whether my system, from the top to the bottom, whether all of it is working correctly together? How do I know whether I can safely deploy bits and pieces of my code? We need to make sure that not only is every box in our system working correctly, but that the things that connect them, the glue between, is also measured and working correctly. So when we feel that we can't get projects done, and even when we do have an hour or two to work on projects to make things better, if we don't have a plan, then we're not actually going to get anywhere, even if I do miraculously scrape together an hour or two of spare time that I'm not spending working on features or fighting fires. So let's figure out how we can fix this, how we can get out of this situation of being so overwhelmed with technical and operational debt. We need to focus instead on how we make our systems more humane to operate. We've forgotten that people operate systems, that we cannot run systems purely automatically, nor can we run systems by burning people out and having them quit every few months. You do not get a stable system by burning your people out. And our tooling cannot necessarily help us here. Our tools aren't magical because they can only help us automate things that we already know how to do. If your organization does not support the overall goal that a tool is helping you achieve, then the tool is going to sit there with no one using it, or people will turn it off because they're not able to actually act on it. So instead, what we need to do is we need to invest in our people, in our culture, and in our processes in order to make our production systems excellent. So this is an overall subject that I call the idea of production excellence, of thinking about how we run sustainable production systems and how we live in a better world than the one that we had 10 or 15 years ago before DevOps came along, before site reliability engineering came along. In order to accomplish this, we need to figure out how we make our systems, and I mean our systems as in our socio-technical systems, the combination of the people and the technical systems. You kind of can't have one without the other. So we have to make those systems overall more reliable and friendlier to the people running them. We also cannot get to production excellence by accident. We have to plan and figure out how we're getting there, because a set of random changes is not going to get us there. So we have to figure out, what are the main themes? What should we be working on? And how do we know when we've gotten there? How do we know that we're working on the most important things that can help us advance the most quickly? In order to do that, we have to involve everyone regardless of their job role. We have to include not just developers, but people who do operations and people who do customer success and support. And finally, we have to think about our business stakeholders, because ultimately, the vast majority of us work for businesses that are trying to accomplish something. So we need to make sure that we're in alignment with the people who are paying our paychecks. And we have to make sure that people feel safe giving their input, that people feel safe asking questions in order to understand how they can contribute and how they can make it better. And yes, sometimes to raise their hand and say, you know what, we need to do things slightly differently because this current track is not working. So how do we get started? Today I'm going to tell you about the 4 key things that you need to do in order to achieve production excellence. The first thing is that we have to know, when are our systems too broken? When are they beyond the bounds of how they normally operate and into the realm of making our customers unhappy? And when they are too broken, we need to be able to debug where the failures are happening, and do that not just as individual people, but instead as teams of people. And finally, we need to be able to close the feedback loop. We need to not relive the same outages over and over and over again. Instead, we need to figure out how to eliminate unnecessary complexity in our systems that is causing outages and causing problems. So to begin with, let's talk about the idea of failure. The idea is that failure is constantly happening in our large-scale systems. As I alluded to earlier, it used to be the case that your systems were 100% up or 100% down. That is no longer the case. For example, if you are running a mobile app and a user of the mobile app cannot connect to you, maybe it's that they're driving through a tunnel. Or maybe the cell service is temporarily not working. Or maybe it's your servers. There's always some degree of acceptable failure. You wouldn't want the lawn in front of your house to have every single leaf in it be green, right? It would cost a whole bunch of money to rip out every single leaf that was brown and replace it with a green leaf. So instead, let's think about measuring when things are broken and measuring how much brokenness there is at any time in our systems. In order to do this, we need something called a service level indicator, or SLI. So a service level indicator and its companion, the service level objective, provide common language for us between those of us who are developers, those of us who are operators, and the people who run the business and pay the paychecks. They enable us to agree on how reliable should we be and how should we measure it. In order to use a service level indicator, we have to first think about what is the common unit of measurement of user experiences. What is an event that represents something that a user is trying to accomplish with our system? Maybe it's that someone can successfully request a ride from Cabify. Maybe it's that we can process someone's payroll so that they get paid on time. Either way, there's the event itself as well as some context surrounding it. For example, we might need to know, where are these users located? Or what's their email address? Or we might want to know what version of our software served the request. These are all important things for us to keep track of. And then after that, we need to have some rules for figuring out which events represent events that are good enough that meet the needs of the user, and which ones represent a bad user experience that we don't want them to have too often. And because I don't want to sit here looking at every request to decide whether it's good or bad, we need rules for robots, for our machines to tell us which ones are good and bad. And if you don't know how to decide, that's okay. Talk to your friendly product manager. Your friendly product manager will know what signs lead to a user having a bad experience, or what were their goals when developing the product specification. And then we can decide on what thresholds bucket our events into good and bad. For instance, I might decide that an event on my website is good if it was served with an HTTP 200 code and it was served within 300 milliseconds. Because I know that if it sits longer than 300 milliseconds, the user might close the tab or go away and come back later. We also have to keep track not just of all of the events, but we have to keep track of which events do we care about. For instance, I don't care about my load testing traffic. I don't care about my automatic health checks. And I don't care about malicious botnet traffic. All I care about is the real experiences that my users are going through. So I need to keep track not just of how many successful and failure cases there are, but also how many total cases there are that I care about. And then after that, I can compute the availability number, the percentage of events that were good out of the total number of eligible events. And then I can establish a service level objective. The objective has two parts to it. The first part is a temporal window. We have to know what window of time am I evaluating this over. For instance, if I set my time window at 24 hours, well, does that mean that my users are going to magically forget that I had a 100% outage a day ago? No. I should run my system a little bit more conservatively for at least a few weeks after I have a major outage. So we have to set a longer window of time that's correlated with our project planning cycles and our users' memories. So typically that looks like 30 days to 90 days for your temporal window. We also need the target percentage. And the target percentage varies by the use case. For instance, if you have something where it's okay for someone to try again, for instance, if they're trying to check out a library book, maybe having that fail 1 in 200 times is okay. But if you have a system that is more critical to people's lives, for instance, if you have a hospital that's trying to dispatch ambulances, maybe you want that to fail much less often, maybe only 1 in 10,000 times. So as an example, I might decide that my objective is to have 99.9% of events be good over a 30-day rolling window, where I define good earlier as it having a 200 HTTP code and returning in less than 300 milliseconds. How do I know whether I set the right service level objective? Well, the right service level objective should barely keep your customers happy and should barely meet their needs, so that they're neither upset with you nor super failing to notice that you've made the service 5 nines reliable because their internet connections are less good than that, right? So ideally, if your users encounter an error, it should be an acceptable level such that they would probably feel okay trying again rather than giving up in frustration. We can use service level objectives for two purposes. The first one is that we can replace a lot of our alerting with SLO-driven alerting. And in order to understand how that works, I need to introduce you to one more concept. That's the idea of the error budget. The error budget represents the amount of unavailability that I'm allowed to have. For instance, I was just talking about a service that has to serve 999 out of 1,000 requests successfully. Therefore, I can serve 1 out of 1,000 requests with an error or slower than 300 milliseconds. So if I serve 1 million requests per month, that means I'm allowed to have 1,000 of those fail. So I can look at how long it's going to be before I run out of that budget. If I am seeing 10 errors per minute, then I know that in 100 minutes, I'm going to run out of my monthly error budget. And that means that I might want to do something relatively quickly. So I might want my phone to wake me up if I'm going to run out of my error budget in a few hours or less, so I can do something about it, so I can fix it and return the system to an acceptable level of errors before we run out. But if we're going to run out in a matter of days, instead, we can create a non-paging ticket or something in our bug tracking system in order to say, hey, when you get back to the office, you might want to look at that low-level amount of failure that's just slightly higher than we anticipated. The second case that we can use SLOs for is for making decisions about how we prioritize our time as developers and how quickly we can iterate. Remember I said earlier that you should set your service level objective so that it meets the expectations of your users and not much higher than that. The reason is that if you're maintaining a much higher level of service than your users expect, then you're giving up the freedom to make changes and to experiment and try things in order to find out whether they work or not. And if you're not doing those things, then your competitors will be figuring out how to make your customers happier faster than you can. So if we have plenty of error budget left, what we can do is we can turn on a feature flag to 1% of our users, for instance, knowing that even if every single request that's served to that 1% fails, that I can roll it back and I'll still be within my error budget. Conversely, if I've had a set of outages or partial outages over a period of time, maybe that's a signal to me that I need to slow down working on features and add more items from the reliability backlog onto the team's set of tasks for the next sprint. Overall, it's more important to have any kind of service level objective than to not measure at all, right? Like, you have to have some notion of what you're measuring first before you try to make it perfect. So think first about measuring even things like from your Elastic Load Balancer or from Google Cloud Load Balancer. Think about using those logs to set your standard before you think about, oh, but it's going to take us months to add instrumentation to our mobile apps, right? Focus on what you can measure right now, and then over time, you can make the instrumentation better. The other important thing is that you shouldn't necessarily assume that your thresholds need to be the same for years on years on years. You can always change what your targets are if, for instance, you had an outage but no one complained, or conversely, if you have an outage and your service level objective didn't say that something was wrong, well, you can adjust the thresholds accordingly. So when you do this, when you alert only on what matters, and get rid of all of those alerts that are something like, the disk got 90.001% full. Oh my goodness, that's an emergency, right? Like, when you get rid of all of those alerts and instead you focus only on when users are having bad experiences, it'll mean that you can finally get some sleep during the night. But that's only half of the picture. Let's move on to the second thing that I want to tell you about today, which is the idea of observability. We need to have observability because our outages are never exactly identical. There's always something slightly different about them. You cannot predict in advance how your systems are going to fail every single time. You might have some ideas, but we always run into unexpected things in production. After all, if you were able to predict the future, wouldn't you be doing something a little bit more lucrative than writing code, like maybe winning the lottery? So let's think about instead how we can design our systems for failure so that we can analyze the failures in the middle of it. We have to be able to ask new questions of our code while it's running in production, because the worst feeling in the world is when a user is having trouble in production and you're stuck trying to reproduce it in staging and you can't, and in the meanwhile the customer is suffering, right? We have to be able to understand novel cases that we didn't predict in advance. And that means that we need to have enough data in order to understand what's going on, and we need to be able to query that data in new ways, to ask new questions. When you aggregate data at ingest, what's happening is you're narrowing the questions you can ask to a finite list of questions, which may not actually answer your question in an emergency. We also have to be able to think about new questions to ask and answer them, right? When you're having an outage, in my experience at least, the thing that takes the longest is trying to figure out where do I think the system is broken, and how can I verify whether that's actually the case. So the faster you make that process and the easier you make it for your team, the shorter your outages are going to be. So all of this is to say that our services have to be observable. The textbook definition of this is from control theory, and it says that you need to be able to observe the internal state of the system based only off of its existing inputs and outputs. But I think the more relevant definition for us as software developers is, can we, without shipping new code, understand what's going on in our systems, whether it be for the purposes of debugging an outage or for the purposes of things like understanding what our user's behavior is. In order to do this, we need to be able to look at each user journey and look at each sequence of events in its full context to understand how is it similar to or different from other events. What were the unique circumstances of that individual request? And can we understand the variance? Can we understand what separates the bad requests from the good requests? Can we understand, for instance, which set of users is impacted, or which combination of set of circumstances is involved in an outage? And even better yet, can you get this data after the outage has already happened and been automatically mitigated? For instance, are we collecting enough data so that if there's a problem in one availability zone, we can automatically shut off that availability zone, send the traffic elsewhere to somewhere that's working, and have the data to look at it during business hours rather than in the middle of the night? So SLOs and observability go together, because SLOs tell you when are things too broken, and observability helps you understand why are they too broken. What do I need to do in order to return the system back to a state of working well enough? But we also need a third thing, and that third thing is that we need collaboration between our teams. Collaboration is essential to debugging problems, because we cannot sustain our teams and services off of heroism. Having individual heroes does not work forever. We need to have people feel free to go on vacation. We need to have people feel free to change jobs. And that means that we need to work together to share the knowledge, because often a solution to an outage is present in more than one person's head if they would only talk to each other. And that means that we need to talk to each other across job roles, whether it be the person working customer support, to the person writing code, to the person fighting the fire in any given moment. And it means that we have to work on our interpersonal communication skills and make sure that everyone can communicate and feel safe doing so, rather than feeling like they're being shamed for, oh my goodness, I can't believe you didn't know that. How dare you not know that? Instead, shouldn't we think about things in terms of, I'm glad you asked that question. Sorry the documentation wasn't clear. Let's make it better together. Isn't that much better? And we need to be able to lean on our teams and work together as a team. When we work together, it means that we can do things like comply with the EU Working Time Directive, or give people their religious holidays off, or help managers do on-call in the evenings and not during the day when they're having sensitive meetings with people who report to them. We also learn a lot better when we document and write things down, and write the right amount of things down so that we're not leaving ourselves misleading breadcrumbs either. We need to get that knowledge written down of, for instance, how do I mitigate this outage? What are the key 5 facts I need to know about this service? And make sure that people understand where to find them, and that people feel safe getting errors in them corrected. We also need to learn from the past in order to make our futures better. And the main thing is that outages are not exactly the same, but there are definitely some common patterns of outages that we have to learn from. And therefore, we have to conduct risk analysis. We have to plan in order to figure out what is a class of failure that we're okay with allowing for now, and which ones are not okay. For instance, if you have a bridge, and the bridge has holes in the road, and cars are falling through it, and maybe the bridge needs to be rebuilt in 20 or 30 years because an earthquake might come. Which one of those is the more important thing to work on? I think it's probably the first thing, right? But we have to be able to justify that decision of, let's let the seismic retrofit wait. So in order to do this analysis for our systems, we have to quantify our risks by how often they happen, how long they last, and how many people they affect. And based off of those three factors, we can figure out how severe is the risk. How can we figure out what endangers the largest number of users for the most time, and therefore that we should deal with? The risks that you need to deal with are those that threaten your service level objective. Remember I said you should have a service level objective, right? If I know that I'm allowed to have 1 in 1,000 requests fail, if I have something that I know is going to cause 1 in 2,000 requests to fail, or is going to cause, for instance, more than 20 minutes of downtime per month, maybe I should go fix that first and not fix that weird random corner case over there. So having this data of saying, this is our promised level of reliability, and these are some things that we're worried about that impede our ability to deliver that level of reliability, that gives you quantitative evidence to take to your decision makers to say, we cannot give you that feature right now because that feature is no good if our users can't actually reach the service often enough. But we have to actually prioritize finishing that work and make sure that we're checking off the most important things and reviewing that frequently in order to make sure that we don't just sit there forever waiting for the solutions to our problems to magically appear. Don't waste your time working on things that are not important. Work on your system to make it just reliable enough, and then go back to working on features, but then be prepared to go back to working on reliability when you need to. But a thing that people commonly overlook is that if you do not have observability, that is a systematic risk. That is a risk that adds to the length of every outage that you have. If you are spending the first 20 or 30 minutes out of every outage trying to figure out what's going on and how to make it stop, that's a lot of unhappy users. So that's a systemic risk, and that's something that you may need to think about addressing. The other thing that's a hidden risk is a lack of collaboration. You may not necessarily see it directly when you do this risk analysis, but if your customer support team doesn't feel comfortable raising issues, then you're going to have issues last a lot longer before you even start working on them. And that's actually a real-life experience that I just had with helping a team in London that had an outage that lasted a week that was affecting everyone using Safari on Mac. And it turned out that their customer support team knew, but that they didn't feel comfortable raising it to engineering, right? It would have been a lot better had they felt safe to raise that a lot earlier. So make your outages shorter, both with observability and on improving collaboration between your teams. You don't need to have heroes for your team to be successful. Focus on building that team. And overall, you need to buy some tools, the right tools that make sense for you, but also make sure that you're making those cultural changes that you need in order to have your company be successful. So use both production excellence and some tools from the alphabet soup as you go forward from today. By the way, I do think that these are things that my company does make easier, but you don't have to use us. The important thing is that you think about how you're fostering this within your teams and using your existing tools. And if your existing tools don't do this, then maybe start looking for some other things to introduce to your team. So when you have production excellence, it makes your teams better because they can measure what's going on, they can debug together, and they can repair things and make your systems better for the future. Thank you very much.